Hey guys, today we're talking about symmetry. Here's your learning objectives. I can determine how many lines of symmetry a shape has. I can draw lines of symmetry. And the other thing we're going to do today is we are going to talk about I can compare and contrast lines of reflection and lines of symmetry. Let's go ahead and get started. So first we have to talk about what exactly symmetry is. And symmetry is when you have one shape, or two shapes I should say, but they look exactly like each other if you flip, slide, or turn it. So I have two triangles on here, and they're turned different ways, but I can find that if I rotate it or turn it, and then slide it over the other shape, they match exactly. So that is a property of symmetry, is that they look exactly like each other, even if you have to flip it, slide it, or turn it. Now, these are not symmetric shapes because this one is way bigger than this one. On my board here, I have half of a picture. And so if I used a transparent mirror, forgot a typo there, to finish this picture, what do you think it would look like? You've kind of done this before with reflections, but if I held a transparent mirror, if I put it on the paper right through the middle here, what do you think you would see on the other side? Well, if you line it up, you might see something like this. Depending on where you held the mirror, you could see something like this, which is a reflection. Or if you held the mirror right through the middle where the picture ended, you would see a heart. So that line where you put the transparent mirror, notice that it's right on the edge of our pre-image. If this is our pre-image and that's where we lined it up, this is what we would see on the other side. Symmetric shape, even though it's flipped, all right? So I want to talk about, though, how is my heart picture on the right here similar and different from my dog picture, which we did in class the other day on the left. Let's look at the things that, that tell us what they're similar with. First off, we know that, get my pen here, we know that both of them, I'm going to write dog, heart. Both of them are mirrored images. That's an M, by the way. So the images are congruent. They're the same size, same shape, the pre-image and image for that matter. All right? Congruent. They're both congruent, so they have that in common. They also have a reflection, so it's a flipped, reversed image. But how are they different? Look at the picture over here. Notice that between the dogs, here's our line of reflection, but there's a big gap. See that gap in the middle? There's a gap between the dogs' noses. So there's a gap between the images, or a space. I'm going to say gap between pictures. So that's different because if you look at, sorry for my bad writing today, by the way. If you look at our heart, that line of symmetry, ooh, I just used a different word, more on that in a second, goes right through the middle of the picture. There's no gap. So that's something that's different. There's no gap between the two pictures. Huh. So this is a hallmark sign of symmetry, my friends. And it's that when you have a line of reflection smack dab right in the middle of that picture between your image and your pre-image, this is what we call the line of symmetry. It's not a line of reflection anymore, it's a line of symmetry. So when we have that, and there's no gap in between the pre-image and the image, we say that the objects or the pictures are symmetric. Remember, line of reflection, we're going to have that gap in between, or that space between the pre-image and the image. The line of symmetry slices right through the middle of the picture, but both sides are congruent. They're just flipped, okay? And we have symmetry all over the place in the real world. I challenge you to look around your house, look around outside. In nature, there are so many things that are symmetric. Down here I have symmetry. If I were to draw a line of symmetry through the middle of my shape here and fold the top to the bottom, they would match. So that's one line of symmetry. If I were to draw a line as best as I could top to bottom vertically, and I folded it left to right, that would be symmetric. There's no gap between the images at all. And if you were to go to the White House and right through the flagpole here, draw a line of symmetry and fold the White House in half, you'd find that both sides are symmetric. They're congruent. They're just flipped mirror images of each other. There's no gap, no space at all between those two images or two pictures. So there's something else about symmetry that we're going to explore in class, but it's kind of a mystery, and I want to see if you can catch on to it. Regular polygons, that means that shapes that have the same size side lengths and the same size angles, so the same side lengths, or how long their sides are, and the same size angles, those are called regular polygons. I'll give you an example. Let me draw a shape for you. This is a regular hexagon. If I were to measure each side length, it would be the same length. And if I were to take, if I were to go ahead and measure the angles, all of the angles would be the same degree measurement. Okay, so I'm going to flip over to my Elmo for a second, and I want you to take a look at something. So I have a rectangle on the paper here. This is not a regular polygon, because why? Because if we look at the sides, this side is way longer than this side. And we know with regular polygons, they have to be the same side length, okay? Even though the angles are the same measurement. But first, let me show you the non-regular polygon way. If I were to fold my paper in half, so I have the two sides match, and I make a nice, oops, that's a crinkled crease. All right? That's one line of symmetry, because both of my edges match perfectly, and there's no gap in between when I open it back up. All right, so that's one line of symmetry. And I can also fold it top to bottom. And that is, see how the two sides match up perfectly? The two images, I should say. That's my second line of symmetry. So my rectangle has two lines of symmetry. I cannot fold it this way, because look what happens. If I try to fold it diagonally, oh my gosh, it's a big mess, because the two sides don't match up. So that is not a line of symmetry, because the two sides don't match up, okay? So rectangles, a non-regular polygon, have two lines of symmetry. But if I had a regular polygon, a regular square here, the sides are the same length, the angles are the same length. Watch how many lines of symmetry I have. 1, 2, 3, 4. So a four-sided regular polygon has 4 lines of symmetry. Interesting. Think about that a little bit. All right, that's all the time we have for today. You think about that, and I will see you later.